Thank you for being here. I'm Jeroen Makkenbach. I'm part of the technical staff within our Dell Edge business unit. I've been working in Edge for about 25 years. Currently, I'm part of the technical marketing engineering group, together with that guy, actually. So today, I'm going to talk about how we can actually secure the edge and how Litmus Edge actually falls into that equation. If you saw the Fraunhofer demo just a couple of minutes ago, the attack surface is increasing, and that's why it's very important that we take a couple of steps to make sure that we are able to enable that. So there you go. A lag on there. What we're seeing is that there's a lot of things happening inside the ecosystem, right? And surrounding the edge. We got a lot of business needs for the security and the compliance, and specifically governments are increasing the security and compliances to make sure that there's law and legislations so that we can actually go after that scum of the universe that actually is doing that. We have an increasing ask for productivity, and we need to increase the customer experience and making sure that that's happening. So the data we've seen is actually received to the maturity level that we can actually reuse that in our AI models. And then we come on to the technology, where we see that AI and machine learning, heterogeneous compute, software-defined, 5G and Mac and multi-cloud are actually going to be used to use that data in these environments. So what it brings actually to us is what we're seeing, that a lot of our customers need to transform, right? They need business agility, they need that real-time decision-making, the operation processes and the customer experience. We need to transform that in order to make sure that we can answer that increasing demand from these customers. And it's going at a pace which is really hard to meet, because what we're seeing is the time to value is going to be increasingly important for our customers. ROI is key there. And that means that we need to modernize our technologies. And a lot of customers are having a lot of difficulties to actually meet those requirements for these environments. Because that's how they make their competitive advantage for their customers, but also for themselves. The difficulty that we see is, how do we do this at scale? I mean, doing a proof of concept is easy. When we start to do this for 5,000 retail stores, for multiple factories around the globe, I spoke with customers today. We have 1,400 PCs inside their manufacturing environments. And the majority of them run Windows NT 4. They haven't been able to modernize that. So improving the security and the safety and the sustainability on these environments is going to be of the essence. They need to be able to use consistent processes to actually reach that, because if they don't have that, everything's going to be a snowflake. Right? On top of that, they need to be able to monitor and control these environments. I've been doing a lot of IoT projects in the past. I was part of the initial IoT team within Dell Technologies. But we saw that customers started a POC, had 10 gateways, and there was an administrator configuring all of that, and that went fine. Until they had about 100 of these gateways, all scattered around the globe, and it became a little bit more challenging. And before they knew it, they had thousands of these gateways and became completely unmanageable. And that's what we're seeing, that people start to build on these snowflakes, and that's why we sort of needed in our strategy to make sure that we can actually attack that. That's where we came with a solution. Because what we're seeing, specifically in the manufacturing environment, is that we're going to meet a couple of very bespoke things which are very out of the comfort zone of the IT departments. We see a lot of environmental diversity, where we need to make sure that in these environments, you cannot use fans. I mean, it could be out in the open. We're going to meet OT workloads, which are very different than what we're running in the data center. Also very legacy. I mean, a lot of these workloads run old Windows environments, and we need to have a home to actually transform this. What we're seeing is a lot of these systems are distributed, and that brings a lot of complexity in connectivity. How do we enable that? In many cases, there's no local IT. If you go to a retail store, you probably have someone that knows how to power on a system and power it off, and can pick up the phone to talk with IT. But about that is the best you can get, right? I mean, specifically in the manufacturing, if there's remote systems somewhere, what we're seeing, for instance, if you're on an oil rig, I mean, bringing someone on site, you're talking hundreds of thousands of dollars because you need to have a helicopter that actually flies someone in. So that's the difficulty. And that's secure operations. I mean, in OT, most of the people work on safety, right? Security is something which is difficult to actually implement. We see a lot of isolation in the Purdue model, but what we're also seeing is that the Purdue model is actually disappearing. So how do we work with that? That's the complexity. And we see all these silos. We talk to large car manufacturers, and what we're seeing is that each factory has their own department that actually does the automation. So it might be a Litmus here, it might be something completely someone else over there. You have Dell here and someone else there. That's the complexity. So that siloed and the proliferation and missing of unification of these platforms is going to be a challenge. So what we're typically seeing, and we've been doing a lot of these bespoke solutions. If, for instance, you want to roll out a manufacturing vision application, what we're seeing is that a lot of these customers are actually going to search online, buy some hardware, they order that, they choose a system integrator, like you, for instance, and that you need to install that application for that customer. That actually decides what that device will have to do in the end. Then you send that solution and the stack over to these different sites. There's might be an SI that does the installation there. And then eventually that install and setup needs to be optimized and tested, right? Now, that really is giving you a very poor experience because in this location, when you do the system integration, you need to actually connect to your administrative platform, and you don't have control later on how that actually will do. So that really results into very insecure environments because you don't know who is in that value chain. And what we've seen, for instance, in point of sales, we found out is that eventually we see performance degradation. And what had happened is actually one of the system integrators had introduced a virus in some of these locations. If these locations are in 5,000 locations, that means that someone with a van needs to go to all these locations, actually removing all these viruses and redeploying these installations. Very tedious, very difficult, and very labor intensive. So what we have is a platform that actually allows us to manage infrastructure at scale and do application orchestration in a way that we can do zero-touch onboarding. And that means that as soon as that device touches the ground, and I will show that later, it actually onboards into a management plane. It also provides zero trust, and I will go into zero trust and what that means for Dell in a later slide. But also what we're seeing is that the majority of our customers have multiple cloud vendors. And that means that we need to be agnostic for who they use and who they want to use. So really an edge operating software platform that is scaled and allows us to do two things. Assure that we can still operate the legacy that's in there because you don't want to touch that. But you want to make sure that once you go forward, you have a foundation where you can build on and start doing things the right way. Making sure that IT is actually going to be able to host operations for the OT. And that's making this whole. So what we're really having is Dell Native Edge. That's your central control plane. And the Dell Native Edge actually is managing that edge infrastructure. And what we're seeing is that we're having native edge enabled endpoints, and that has security implications. I will go into that later on. But what we also can do is we can manage other infrastructure. And here we see that we have a native edge OS on top of the native edge enabled devices, which is fully secure. And we can connect our control plane to Kubernetes and vSphere environments. That allows us to host applications and deploy applications into existing environments which are already there, right? And still do cloud native practices. Then on top of that, we have a hypervisor layer that allows us to run VMs and containers. And on top of that, we have our applications, Litmus in this case, right? So centralized management of any devices and applications that might be out there, secure device onboarding and deployment with zero touch and zero trust. I'll go into that later. It will free up a lot of time in the automation from day 0 to day 2, because that's all being taken care of in our onboarding strategy, and allows us to do that day 2 operations and beyond and full lifecycle management. We have a lot of these validated designs already in our catalog, but we're free to choose any IoT framework on top of this, or any OT system that customers probably are already running. On top of that, we can do that with any cloud vendor. We can deploy VMs and container applications to existing environments, for instance, a VxRail. So here's our onboarding strategy. So at the point that you order a device from us, what we're doing in our manufacturing building, we're actually manufacturing a device in a DI process, a device initialization process. Now, the result of that DI process is a voucher. That voucher is your access token to that device. That voucher actually meets that device on the point of creation, instantiation, and configuration. Now, during that shipping and installing, essentially those devices are bricks because they miss that voucher. And I mean, we completely lock that down. You don't have access to the BIOS. You won't be able to boot any other OS than our bespoke Dell Native Edge OS. We completely divert everything into that control plane. That means that if you want to change a serial port, you go into the control plane, and in the control plane, you set it from RS485 to 232. That's a very novel way of doing things. So during that shipping and installing, no one can access that device. So that is a secure transit. So this is your software validity, but on the hardware side, we have some other enabling technologies, which is our secure component validation. So if during that shipping and installing, there's a nefarious person that will actually want to install, for instance, a network controller that can sniff on the network, or change a memory module with something else, when that device on board, we'll actually be able to detect that and see what has happened on that device. So it raises the flag and say, here we want to stop. So literally, if you go into the Dell Native Edge Zero Trust architecture, what we've done is we've done a project with the DoD and NIST in the US. That was called Project Forward. And Project Forward is actually a learning phase for us on how we would actually architect a zero trust architecture. That zero trust architecture, along the 7 pillars that you see here, has actually allowed us to gain all that learning that we've done with them and actually incorporate that into the Dell Native Edge platform. So that means that all the user, the devices, the network, the data and the application that we're actually incorporating into our total solution, we'll be able to completely automate and see and have telematic analytics over these to make sure that all of these entities have an identity and have an authentication, and we constantly do that. So anything that deviates from the known good, we'll actually be able to detect that and mitigate with automation and orchestration in these environments. So on top of that, what we're actually able to do is actually streamline our DevOps solutions. So we have the ability to actually blueprint solutions for our customers. These solutions are validated, and in these blueprints, we actually have a recipe on how good would look once this installation is deployed. So we create these blueprints, and those blueprints are actually a recipe on how we want to orchestrate and lay these applications down to these devices. So what we're doing is we're having a couple of recipes included, including, for instance, SSH keys. You want to include naming conventions. You want to include the targets. You want to include the sources. Where are the binding sources for these devices or for these software endpoints? So all the artifacts, the SSH and the public keys are actually hosted in a vault. And that vault is actually secured by a Shamir sharing algorithm. So that means that all the users that are going to make use of that vault are actually the consortium of those people is actually securing that vault. If someone is actually removed from that, we have to reshuffle that. If someone is not part of that, he won't be able to access those keys. So that's a very secure way of actually doing that. Now what we're doing is actually automating the process of how we want to lay down these environments. But what we can do there as well is actually retract that. So today this is a Litmus solution. If tomorrow we want to have a Microsoft solution in there, an IoT edge solution, we could deploy that on the same hardware in the same way. What we can also do is actually verify if that solution is still valid and if everything that we deployed is still going as it should be. So that allows us to actually secure that environment and making sure that, for instance, if ransomware enters these locations, we can actually do a verification and a redeployment and making sure that it's cleaned up and redeployed. So that's a very secure way of actually making sure that the entropy of those environments is secured. That's really the beauty of the whole native edge integration. There we go. Now it stalls. There we go. So if you look at how we actually deploy ads and how we manage ads, we reimagine how we do that. So we have an application catalog with all our validated designs already in there, which is off the shelf, could also be a homegrown or any cloud native runtimes. We provide a lot of automation that delivers these two edge devices with a standardized and hardened and a customized environment. We apply the zero trust and zero touch provisioning, and we do that in a multi-cloud environment. And we can remotely manage all of these endpoints over time. We monitor, secure the life cycle of these applications and these devices while we're running these. We do that with global support and services, with secure supply chain and our partner ecosystem like Litmus. So why Dell? We have the broadest portfolio in the industry in terms of the hardware and the software ecosystem. We have a global ecosystem of partners like Litmus, our reliable supply chain, It allows us to generate insights with these partners, which we haven't been able to do before. We can consolidate while you're expanding because you can expand on the existing hardware which you already have. And we can bring modern security to the edge where this is actually needed to go. So this native edge, it's live. We're actually going into version 2, which is being shown here at the booth. That's hall booth D53 in hall 15. And we'll help customers doing the complex challenges. Thank you. Questions? You got to be on video.
Okay, so my question is, one of my questions is, you're going to deploy these gateways down, or these native edge gateways, let's say. How do we spec how much coverage, or how do you size the gateway to the application? Not the Litmus, but the end solution.
Yeah, good question. So the sizing is done by our engineering, right? So we work with Litmus on these validated designs. So if you're talking about tags that you actually want to drag down during your data fabric, and you want to store those, we actually have scaled this and skewed them up and making sure that, and he's responsible for most of this, to be honest. So he helped to actually scale this. So if a customer says, listen, I have an application that uses 600 tags, we'll know how to license it, how to scale it, and that means that you're probably going to end up with an edge gateway 5200 that can consume 600 tags, and this is how you actually can store them into your environment. So we have examples and scaled how we actually gonna do this. So
I have a question as well, thank you. You talked about the legacy application that exists in the OT environment.
Yep.
And there's lots of them, right?
There's lots of them.
And that often is the reason not to change is kind of illustrates. So what's the process of taking a legacy application, an NT4 application that's sitting out there on the factory floor today, how to bring it into the native edge environment? What kind of process, in addition to scaling, do you need to go through?
It's a very good question, right? Well, I've written a white paper about industrial protocols, and what I found out during that journey is that the majority of these industrial protocols have no ciphering and have no authentication, which in the modern world is a big problem, especially if you go back to my zero trust environment. Here, all of these entities need to be identified, ciphered, and authenticated. If that's not there, probably we can assume that that needs to be isolated from the IT environment. Yeah, and that's what we're doing. That's why we're using VMs to make sure that that NT environment can actually run in an isolation, completely memory isolated, completely separated from the platform. We can actually make sure that the data that's produced in that environment can actually go into a conduit where it actually can communicate to a trusted environment, which might be a Kubernetes environment. And that's why we also need in a lot of these cases like Litmus to actually aggregate that data, because they have all the drivers that can actually consume these environments, right? So that will allow them to actually start working into these cloud native new applications, because that's essentially where things will go to, right? And essentially what we can see is that NT environment can still be part of that initial environment, whether that NT environment is hosted in our platform or still runs on the same hardware in that environment, and we're going to actually take out the industrial protocols out of that. So there's two ways of doing that, right? What we ultimately want to do is gradually move to a cloud native environment and do that in a very agile way over time. But I know that a lot of the use cases that customers will have will need to be treated and transformed into this environment. So that's really how we do that. Ultimately, the only thing that we need to do is make sure that we can blueprint these. And in a VM, that would be really easy. I mean, you throw that into the environment and you can run it there. The advantage there is that you can take that legacy application from that workstation that's probably there for the last 20 years. I mean, if that breaks down, what are you going to do? Because most likely that's not going to work anymore. So that's why we change these architecture, where you actually can consolidate these different workloads into one legacy application, where you have the overarching security model, which allows you to actually bring in a lot of goodness there in the environment. So. Good? More questions? Good. Thank you very much. Thank you.